Hello, everybody. My name is Dev Comboy, and today I'm going to talk about databases. So I've kind of condensed this presentation just because each slide is there's a lot to talk about. So I've limited my amount of slides, and we'll go more into detail than is on the slides. But just in terms of condensing everything, I've shortened up the slides. So databases and database types. What is a database? You might be wondering. A database is an organized collection of data. That's the textbook definition. It's any organized collection of data. But the more modern term, a database management system, DBMS for short, is kind of what a company uses to store and analyze information about their users, about their own clients, about people within the company. You can host a lot of different information. But let's go into a database and kind of what it is. So there's a few different types of databases. Those include MySQL, PostgreSQL, Microsoft SQL Server, Oracle, Sybase, IBM DB2. They're different formats for storing information. A database is not generally portable, so it's not like you can just take one database and then use it on another, like an application or anything like that on an iPhone. But it's more specifically designed for each purpose that the database is being used for. So databases are not data farms. They don't just store data. They're custom designed to actually tailor whatever the company's data is and analyze and report it in a way that's kind of user friendly. So it's not just a place to store information, but it's also that aspect of looking at it and using that data to make informed business decisions. Most databases are internal, so they live inside the 100% of the company. But a lot of databases today are expanding out to an OpEx platform, which means operating expenditure, to where instead of just buying that whole computerized system up front, they're now being kind of moved to the cloud and pushed out to other services, software as a service providers, so that their capital expenditure can be decreased and their operating expenditure increases. So let's go into the types of databases. SQL or SQL. SQL is a specific language widely used by databases. It's an industry standard, with one of the biggest ones being MySQL. MySQL is an open source relational database management system. They call it RDBMS for short. And basically, it's a popular choice for web apps and central components, and they run off of a bunch of different platforms. Actually, ironically, all platforms besides Windows. So they manage the data, combine and use command lines. This one's a little bit less user friendly, I would say. You need more of a ITM guy to kind of be able to read and use the database. But once it's all set up, it's designed to report information. So another few types of SQL databases, Oracle, Microsoft SQL. SQL is just a language. It stands for Structured Query Language, special purpose language designed for managing data held in relational database management systems for stream processing and in RDMS. So it uses relational calculus and relational algebra to manipulate and interpret data. And this was one of the first commercial languages. So this is kind of an industry standard. It's ANSI certified. It's certified by the ISO and is used a lot today. NoSQL databases represents a whole different type of evolution of databases. And it's really come out of a necessity for huge user interface platforms, kind of like Google and Facebook. I mean, a standard database was not robust enough to handle the amount of users, the amount of inputs and and outputs that a SQL database could handle. So they developed this, and it's kind of a term for not the standard, NoSQL. It doesn't use structured query language. There's hundreds of other different approaches that they use, and they're better able to manage very, very large formats, such as Google and Facebook. Other databases include Oracle, Sybase, DB2, and others. Some people don't have the ability to code their own database. So, in terms of entrepreneurs, smaller format businesses or larger format businesses, things that don't really fall under that SQL or NoSQL category would be more inclined to use something that doesn't fall into the structured query language or the non-structured query language model. So kind of the evolution, SQL, the structured query language, was the first. It started based out of this need to start, relating information to what that information means. And then Johan Oscarsson of Last.fm kind of brought up this term, NoSQL, which really described, this up and coming non-relational data stores. And, that he came up with this term based out of the necessity to classify databases, that Amazon and companies like Google and Facebook used, because nothing really had existed to classify them before that. And then again, the others, a lot of others are used today, especially again with small businesses. So this is kind of an overview of what a database looks like. On the left, you see this window, and it's got a structured query language file. Most of the people watching this video probably would not be able to read what that stands for. So again, you kind of need, when you're going in and setting up the database, structuring it, and looking through some of the information, you really need to know what you're doing. You need to know, computer languages, C++, stuff like that, so you can really understand what the database is trying to communicate to you. And then in the middle, we have this little, or on the right side, if I apologize, this graph kind of shows you what the environment looks like. So you look at the right side, and this kind of shows you the cloud and how people access the database. So you see the internet in the cloud here. You see the customers, you see, the competitors, and then you see the arrows facing left requesting the database. That goes to the hardware of the computer. So this will actually be placed at the company itself, or if it's using a cloud system, it would be placed at the data farm. These are the physical computers and networking and storage that the database uses to store all this information, and then it goes into the software here. So the Linux kernel, this is one example. Linux is a platform much like Macintosh or Windows, and that's what this SQL software is running off of. And then on the left, you see the different databases, the CGI, scripting, the web server, and the web cache, which are all four components of what is used to make a database. So implementation. So in the early days, it really did have limited access. Nowadays it's, all about online interactions with customers and suppliers, these enterprise softwares. But in the early days, it started with like, flight reservation systems and websites, very, very, very simple. And now today it's incredibly complex. There's an insane amount of information that goes into databases. So we took this integrated approach. IBM's prototypes, COD concept, System R was one of the first databases out there. And, that was where multi-table systems and data splitting started taking place, where you stored these chunks of data, and it was more of just a storage. Nowadays, it's in the 2000s, that NoSQL and the new SQL, these XML databases are very very complex, and can do a lot more than they used to. Here's a picture of what a data farm looks like, and then line item database and inventory tracking. So yeah, like I said earlier, they're applying more than just information. They're tracking huge quantities of inventory. For example, Amazon's millions and millions of dollars a year go into just the maintaining this database of their inventory because this information is so pertinent to their business operation. Here's an example of sorry, let's go back here. This is an example of a packaging machine and a bending machine. And when a product goes through in the one machine, the one machine will store information about the product, which product it was, make a barcode, and then put it into a database. And then the other packaging machine will then read that product and read the barcode on it and gain information about the product. So even in terms of manufacturing, this databases definitely apply. So database, how do you access it? This guy right here, let's just call him Jim. Jim is actually touching this network switcher here. This is where all the information is stored, and he is the guy to go to in terms of analyzing, reporting this data. The regular company manager probably doesn't have the access that this guy does. The IT manager position, it's very limited access, and it's both for security reasons as well as an understanding reason. It's very hard to learn computer coding, especially like languages like C++. These are languages that are like learning a new language entirely. So, in terms of a skill level, it's kind of hard for the regular consumer to access these databases. But once they're learned, these positions are filled by IT companies. So hopefully that was a little bit helpful, and we learned a little bit about databases and database management. Thanks.